I'm speaking with Professor Amitabha Ghosh
Hello, Roy.
in the Delta Hotel in Montreal on June 17, 2015.
Correct.
Welcome to Montreal
Thank you.
again.
The fifth time.
Okay. We would like to discuss your theory of inertial induction. Okay. My first question, as always, is how did the idea of inertial induction, or the process of discovery of inertial induction begin?
Oh, actually, the motivation behind the whole thing came from my teaching the subject mechanics to my students, and I wanted to explain the phenomena of inertia. And then I was studying a little bit about Mach's principle and came to the paper by Denis Sciama, who first tried to quantify Mach's principle. And obviously I was very impressed by looking at the derivations and his logic that the effect of the rest of the universe's mass is the cause of producing inertial resistance to the acceleration of a mass. But I think I was somewhat not convinced by the completeness of his logic, because to make the gravitational mass and inertial mass exactly equal, it required extreme fine-tuning of various quantities Professor Sciama was using, like the size of the universe, density of the matter in the universe, and so on. And somehow it didn't appear to me that nature will help us so much by conspiring all the values in such a way that the inertial mass of an object is exactly equal to or identical to the gravitational mass of that object. So I thought that how the whole process can be naturally taken care of, and I thought that something like an feedback mechanism or servo mechanism must act, which will make the result independent of the quantities like mass, energy, density of the universe, the size, etc., all those things. So it was obviously a kind of, in the playing mood, I toyed with the idea of adding another term, and that adding another term dependent on also my earlier thinking in the whole matter, that why only acceleration has effect on motion, why not velocity? Because there is no obvious reason that why velocity should not have any effect. One thing could be that effect is very small. So I thought that okay, let us also have a velocity term, in spite of the fact that in the book by Denis Sciama it is written that K-meson decay experiments have shown velocity not to have any effect. But that the level of the effect was such, and the accuracy of the K-meson decay experiments were such, that it was quite possible that an extremely small value will not be detected by K-meson decay. So I just added that term, and then with little bit of working, I found that I am getting a new force law where exactly we get A physical to ma, but over and above we get an extremely small drag, which I have given the name as cosmic drag. So that is actually the influence of the rest of the universe on a moving mass particle. So the basic theory I had to start as an interaction between two isolated masses and their interaction. And when I integrate it over the whole universe, then obviously the results which I get is equal to just Newton's second law, A physical to ma, plus an extra term which is the cosmic drag, and which is extremely small. And now to test it, the only things available to me was the fastest object like photons traveling longest distance, that means light from the distant galaxy, where the effect is expected to be pronounced and measurable. I found that this drag produces the cosmic cosmological redshift. without any expansion of the universe, that means not considering the redshift to be of Doppler nature, I think you get exactly the same value of cosmological redshift. It also gave some indirect support by, when I looked into the literature, I found that the Hubble constant, that is the cosmological redshift, is not exactly isotropic in the directions where mass density of the universe is more, it is more. In the directions where there are big voids, the drag effect is less, obviously, and so the cosmological redshift is also less. So these were the kinds of things I got, and my colleagues also were very impressed in the physics department. And particularly they were very impressed by seeing that F is equal to ma comes out directly from the gravitational law, and which establishes the exact equivalence between the gravitational mass and inertial mass. Yeah.
What determined the particular form of the velocity term which provides the servo mechanism you need?
You see, initially I was thinking it will be a term proportional to velocity, but later I found that it has to be square of velocity for various reasons. And so therefore ultimately it was a term very similar to the acceleration term, but only having a velocity square term. Apart from that, I also used, which was not there in the original work of Nishiyama, that the inclination effect, if the vector, the acceleration or velocity vector, the angle it makes with the line joining the two particles, that will also have an effect. Now there I thought this way, that if this is a particle and there is another particle and its interaction between the two I am trying to figure out. Now when the maximum change in the configuration, relative configuration, is when it moves straight this way. And the minimum change in configuration, relative configuration, is when it moves tangentially. So therefore I thought that if it moves tangentially, effect will be zero. And if it moves in this direction, effect will be maximum. At the same time, it is very important that if acceleration is in this direction, it will be a drag in this direction. So if the velocity is in this direction, drag will be in this direction. If the acceleration is in this direction, the push will be in the other direction, and so velocity also will have a drag. Now, since I am making the velocity term square, now it is very important. That means if you simply make it velocity square, then whether it is moving in this direction or this direction, the moment you make it square, the term will be always same. So you will not get a drag effect. So to make it a drag effect, we have to multiply by a factor we assumed it to be cosine of the angle and into mod of cosine of that angle, which will make the force always a drag. So this was an essential requirement in my model, that force due to inertial induction will be always opposing the acceleration, and it should always oppose the velocity. It is a resistance kind of thing. So simple velocity square would not have done that. I had to use this inclination effect, which is cos theta mod cos theta. It could be some other function, but we thought that it is satisfying the basic needs, making it maximum when theta is 0 and making it 0 when theta is 90 degrees with this. With that, I found that the numerical values I am getting, which was very interesting, that I didn't have any free adjustable parameter in the model. So when I just apply these, only values which was there was g, which is known already, the velocity of light, c, also known, and no free parameter. So I thought that if this produces the quantitatively correct result, it must have something in it. That is very important. If I could have some adjustable parameters at my choice, I can always fit anything. But here I didn't have that. Then I think this is the way first I got the idea, toyed with the idea of adding a velocity term, which will generate the servo mechanism, or it will attenuate the gravity effect, which in turn again nullify the requirement of fine tuning to make the equivalence exact and identical. And then once I got that first result of an interaction of the particle with the rest of the universe, considering it to be infinite and static, I got the cosmological redshift and I got the second law.
How does the velocity term compare with, say, the Seliger-Neumann term?
There, the Seliger's term, etc., is simply velocity square. It doesn't result in any drag. It will not give you any cosmological redshift.
But is in the full theory of inertial induction, is the Seliger effect incorporated?
No, Seliger's effect is there, that there is a velocity term, velocity square term,
Yeah.
but I think it was simply velocity square. So the term, only its value, magnitude depends on velocity, but the force you get is not opposing any velocity. So that does not produce either the exact equivalence, nor does it produce the cosmological redshift or any cosmic drag.
So the drag is an effect that is over and above the normal Newtonian attraction.
Yes, exactly.
But it cannot be expressed in the same way as, say, magnetism, because it operates in different directions.
In different directions, and secondly, magnetic effects, whatever my information goes, is a force which is decided by the distance between the two magnets. Now, if the velocity between the two magnets produce something extra, I don't know. I feel such effects will be very difficult to determine because gravitational effect is extremely small compared to electromagnetic effect. So therefore, where electromagnetism is involved, all gravitational such effects will be almost imperceptible.
And has the theory been confirmed in terrestrial or solar system experiments?
Exactly. Actually, after I got the first result, my intention was to find out if I can express the most important and curious thing, the equivalence of gravitational and inertial mass, which was nothing but an outcome of when I derived Newton's second law from gravitational law. So Newton's second law is not a separate law. It comes out from the gravitational law. Then I thought that, okay, maybe cosmological redshift also I am getting, but what about other effects? So then I started applying this model to two different kinds of interactions. One is interaction of a matter with light or photon. Another one is interaction of a matter with another matter particle. And there were ample examples in the published literature. So when I considered the unexplained excess redshift of the solar limb, which has not been possible to explain, I found that yes, I can explain the whole thing quantitatively correctly. Then I think I also saw some old experimental data which could not be explained, is that when a photon grazes the sun's disk, there is always an excess redshift when it grazes past the solar disk. This was actually suggested to me by Professor Jayant Vishnu Narlikar, that please check what you are getting. So I found that when I investigated two cases, one was the artificial satellite Pioneer, when it went to the other side of the sun and its signal was grazing past the solar disk, and excess redshift was, or excess frequency shift was found, and quantitatively it was matching what I get applying the principle of inertial induction or velocity dependent inertial induction. Acceleration dependent inertial induction I will discuss later, but I found that local effects are more pronounced in case of velocity dependent part, and universal effects are more pronounced with the acceleration dependent part.
What about, say, the grazing, light grazing a galaxy or a cluster, passing through a cluster of galaxies?
You see, with my limited resource, I could find two cases where a light from a distant star was grazing past the solar disk during that I checked and the results matched. This was done in the 60s, and I saw that published literature where they showed that some unexplained redshift was there of a star when it was very near the solar disk, and they did it during, I think, solar eclipse. Again, but in case of Pioneer, it's a man-made satellite, and that data was also available. In both the cases, the quantitative results were matching the theoretical prediction. So therefore, grazing pass, when it passes through that, I explained that. The excess redshift of the solar limb, of that means the extra redshift of the light coming from the periphery of the solar disk, which was also earlier difficult to explain. There had been attempt, but I found that I get the result very easily. And the other thing what I also found, that I tried to consider what are those bodies which will produce large redshift. The body will have to be very dense, very heavy, and also small. So white dwarfs are such objects. And then I found very interesting thing, that there was published result about white dwarf. They found a very interesting thing, that when they measure the mass or estimate the mass of a white dwarf by observing the redshift of the light coming from that, they were getting much higher value than when they were measuring or estimating the mass of a white dwarf by applying other astrophysical means. So reason was very simple. So I collected all the data. So I found that when a photon comes out of a star, in the conventional physics, according to relativity or whatever it is, that the gravitational redshift is there. But this velocity dependent inertial induction produces an extra redshift due to the drag. And so therefore the total redshift you will get out of thing, which will be more than what is simply you get by the gravitational redshift. So what was happening when I applied the formula for gravitational redshift to estimate the mass, whereas the redshift is due to two effects, then mass was coming to be more. And the other methods when I employ, so the average mass of a white dwarf was coming about 50% of the solar mass. And whenever I apply the gravitational redshift method, I was getting about 80% of solar mass. So this discrepancy existed even with a large number of white dwarf cases. But now if I consider that the redshift is due to two effects, the gravitational redshift gm by c square r and the velocity dependent inertial induction term, then I estimate the mass using that, I find that there is no discrepancy. The astrophysical and other methods are giving whatever result, the gravitational redshift method gives the same result. Now here I was once also asked that there was an experiment conducted by Pound and Repka, which is known as a very famous as a falling photon. So they showed that the gravitational redshift on the Earth, they measured accurately. They said that how come that effect was not seen there? When I looked into the published actual paper, not the books or textbook, I found that reason very simple. The effect was something of the order of, for that height through which the photon rises or falls, was 70 feet or something, I don't remember exactly. So the amount of fractional shift, redshift you will get, it was of the order of 2 into 10 raised to minus 15. But when they measured the redshift of a photon going up, they found the redshift they found was 18 into 10 raised to minus 15. And when the photon was allowed to fall, the redshift was 14 into 10 raised to minus 15. So what was done that when one value was subtracted from the other, so one was a blue shift, other was a red shift, so they added up, and other extraneous effects which were there, they got cancelled. So they divided by 2, that 4 divided by 2 became 2. But if the velocity dependent term is there, then that 18 will include not only 2 into 10 raised to minus 15 of the gravitational redshift, another same value, similar value for the drag term. But the drag term will be positive in both cases. So when you subtract, that also gets cancelled. So by this two-way experiment, this effect can never be detected because it will always get cancelled out. Whereas the ordinary gravitational redshift will be positive when going against, and it will be negative, it is a blue shift, when it is falling towards the gravity. So Pound and Rybka experiment, or later similar experiments which are conducted using a satellite by Vessart and others, there is no chance because they are all two-way experiments.
So the redshift caused by inertial induction, the drag, is quite separate from the gravitational redshift.
Yeah, because this will be always positive, a red shift. It will never become a blue shift, this velocity dependent, because it is drag, always loss of energy.
But can the gravitational redshift be derived from the general theory of inertial induction, from the three-term force law?
Yeah.
You can obtain gravitational
Yeah, the other,
redshift
I mean, the standard gravitational
without general relativity.
I think if you consider photon to, you take photon's mass, I think it can be derived.
Assuming a photon mass.
Yeah.
Okay. We know a very a phenomenon called gravitational lensing is observed very frequently in astronomy, which is simply in general relativity, it's the equivalent of the light bending effect. Is there a light bending effect in inertial induction?
Inertial induction, you see, light bending effect is there also in Newtonian mechanics, because in the moment you have any particle with some mass, it will be always attracted by gravity. Only the amount of the magnitude is in question. So anything here also you will find it will have, of course, since it is a drag term and always opposes the relative motion between two bodies, its effect will be somewhat indirect. But gravitational bending is there even without relativity, and so gravitational lensing is okay. Whenever there is bending of light, the lensing effect will be there.
Is it possible to determine the rest mass of the photon from the phenomenology
I think those are
inertial
matters.
induction?
I think Mach's principle. My work was on extending the principle of Mach. So there, the question of these particle physics or all those things do not come. So I have neither any expertise in that, nor I had any occasion to do that.
But you do not need to assume a particular value in order for inertial induction to
No,
apply?
that is obvious. That is your Planck's law, If the photon has a frequency nu, its energy is h nu. And its mass will be divided by c square. That is according to Newton's, Einstein's special relation E is equal to mc square. That has been proved to be correct.
So there's no base level of the photon mass, of which higher frequencies represent multiples?
I don't get the question what you are saying. If a photon has a frequency nu or lambda, whatever it is,
But so the mass becomes variable.
yeah, obvious.
So is there not a base level, a baseline?
I don't know if whether the quantification of the photon mass, etc., all those things, what becomes the basis for quantum mechanics. I haven't looked into those things because those results were not of interest to me when I'm trying to figure out that whether the two mass particles interaction, one is gravitational force due to their just presence itself, One is that what Siyama proposed, that Marx principle, that acceleration also produces a term. I added a separate term, the velocity term, but its implications are far more serious. That's what it is. It is not just adding a term, it changes the whole thing.
Mhm.
And then the other type of effects I started considering, the interaction of mass particle with another mass particle. And there again I was extremely impressed to see that many things, like say there is a possibility of transferring angular momentum from a spinning body to another body without any physical contact, which is not possible in conventional physics. So I applied it to the problem of, very curious problem of solar angular momentum. You all know that the sun possesses 99.9% of matter of the solar system, but it possesses only 0.5% of the total angular momentum of the system, whole system. This is very curious because the whole solar system was formed from the same cloud which was rotating. So angular momentum was contained in the matter. How come this becomes so disproportionately distributed? So now it is more or less agreed upon that solar angular momentum has been transferred to the planets. But what was the mechanism? So Fred Hoyle did a lot of work on that, and it was found that during the formation of the solar system, that before it came and reached the main sequence, that means when nuclear synthesis started, then it was full of dust, and the situation was such, like say your solar wind rays, etc. Considering that, they found that it is possible to have a kind of connection with the sun and the planetary disks or the planets. But that way, this effect would have been possible only during the pre-main sequence period. Once it is in the main sequence, the solar radiation removed all the debris and dust. There is no further transfer. So, but I found that inertial induction can transfer the angular momentum continuously without physical contact. So, in this theory, what I found that the current distribution of angular momentum between the planets and the sun I am getting. I use the data used by Hoyle, the initial cloud mass, its initial angular momentum. I could explain the whole phenomena, how the solar angular momentum was transferred. Secondly, I could also explain another curious thing. It has been found that all stars or suns which are just born, they always rotate much faster. But a sun which is pretty old, it runs slowly. Why it should be so? Now, in the conventional physics, what they say, that most of the angular momentum gets transferred before it starts its main sequence. So once it enters the main sequence, which is the main period of a life of a star, so there should be no further major change in angular momentum. Only small changes should be there. But according to the inertial induction, the transfer is taking place continuously. So the major amount of transfer of angular momentum will take place during the main sequence period because it is much longer. It is of the order of 10 raised to 9 years, whereas pre-main sequence period is only 10 raised to 6 or 7 years. So therefore, according to this theory, all old stars has transferred most of the momentum and they are slow. And all those stars which are just formed, they have just entered the pre-main sequence main sequence period. Majority of the angular momentum has to be transferred. It is still there, so they will be fast rotators. Another thing I found, that once this transfer of angular momentum is possible, then why not the Earth's angular momentum gets transferred to other bodies? So that way I could explain the secular retardation of the Earth, which is now very well known, without considering the tidal phenomena, because tidal phenomena creates other problems. Because if it is purely by tidal phenomena, then it cannot calculate that what is the exact torque of tidal friction, but you have to assume that it is there the required value of tidal friction. Now, with that assumed value of tidal friction and that angular momentum Earth is losing, it is going to Moon. So Moon is receding. So in the past, Moon must have been much nearer, and that is against all geological evidence. So it is a major hurdle in the tidal friction theory. But I found that if you consider the rotating Earth just in the presence of the Sun, it gets the same retardation which we actually observe. So the actual value is about 6 into 10 raised to minus 22 radian per second square, and I am getting about 5 point something into 10 raised to minus 22 radian square. Only little bit has to be through tidal friction, that is there, but much less. Then I considered what about Mars. Now Mars is much cleaner because its two satellites are extremely small, Phobos and Deimos. It cannot absorb the angular momentum of the Mars. So if they absorb any amount of angular momentum for Mars, they will go out of the solar system. So I found two things, that Mars's secular retardation has never been measured. So I have given a proposal to NASA that if they can accurately measure the Mars's rotation rate and find out if Mars also has a secular retardation. I have estimated the value, which is approximately 1.1 into 10 raised to minus 22 radian per second square. If something like that is ever found, then tidal friction cannot explain, primarily because there is no big satellite of Mars to pick up that much of angular momentum. Apart from that, I found out that the Phobos and Deimos, their orbital decays and orbital rate changes, I can exactly find out from inertial induction. So like say, and then most recently, of course, it is very similar to Phobos, our Lagios. Their orbital decay also I am finding out to match.
Lagios is being a satellite.
That also is matching. So wherever I apply this law, velocity dependent inertial induction, for local phenomena, local phenomena, acceleration dependent part plays a little role because it is a long range force. Its magnitude is small in the short range. The effects are small. So I found that matches everything. Besides, it also removes many other paradoxes in Newtonian mechanics, like gravitational paradox, the potential paradox, all these things, Olbers paradox, they are all eliminated. And I also applied this to other exotic cases, like the flat rotation curve of galaxies, which are that whenever any redshift is considered to be an effect of motion, they have found that the redshift, the rotation rate of the spiral galaxies, and they have derived that you keep such a thing bound together, there must be huge amount of dark matter. But if you find out the true velocity dispersion, which is the real, there is some velocity, but if you find it out, considering the effect of this, then you find you don't require that much of dark matter at all. So there is some amount of matter which is non-luminous, that is good enough to take care of that. So that also I have shown, and that was a paper which was presented in Princeton conference at NASA. I also then tried to see that why the rotation curve of spiral galaxies, it is a flat rotation curve, speed. So I found that this velocity dependent inertial induction always interacts with various layers of the parts of a galaxy, spiral galaxy, in such a way that in equilibrium situation the rotation rate will be flat. So these are all indirect ones, but everywhere I found that the same simple formula, without any free adjustable parameter, is producing the correct numerical values.
In the model of the black hole from conventional relativity theory, there is the black hole, of course, spins and has an accretion disk, which is also rotating. So with the very, very high masses and high rotation rates of a black hole accretion disk, would you expect to see any effects due to...
It should be there. And of course I have not done such strong, intense gravitational fields. I have not considered. My primary interest was, as I mentioned, to show that Newton's second law is not a law, but it is actually a derived formula from gravitational law. The phenomena of inertia and phenomena of gravitation, they are same. And that is why they are not delinked, and that is why the mass which we call as inertial mass is nothing but the gravitational mass, because that is the thing which we take. And also I found that the most devastating consequence of this has been that velocity term. It produces a drag, cosmic drag, which generates the observed cosmological redshift. You don't have to bring any concept of expansion and all those things. So universe is infinite, quasi-static, some random motion. And overall, if you see, non-evolving. Locally, there will be evolution, galaxies will be formed, they will die. But as a whole, universe is evolving. It's not necessary. It is a universe which satisfies the perfect cosmological principles. Non-evolving, always existing, always same, homogeneous in the very long range, and eternally the same.
Does inertial induction imply other changes to the laws of motion?
What are the changes?
There are three.
No. I think, the first law of motion is not really a law. If I tell that if a man never falls ill, he lives forever, is it a law? It is not. It's a conditional thing. So what is the first law? If no force acts on a body, it moves forever. But that situation can never happen. There can be nothing in the universe which can move without a force. Even in deep space, it will be subjected to cosmological drag. So
it's an abstraction that
it is an abstraction saying
one
that,
step too far.
Yeah, so therefore it has got no meaning in my opinion. Nothing can move without a force. There will be always a drag. So how can it move forever? So I think it is a law I have also proposed, first law of Amitabha Ghosh, that if a man never falls ill, he lives forever.
Yes.
So first law is something like that. Second law is actually not a law, but it's a derivation from the law of gravitation in the extended form.
Well, I'm sure that the people at NASA or at CERN will begin searching for the eternally living man. It will be a very expensive experiment.
No, but it will be the most unfortunate one, because our real comfort comes to that we can get rid of our problems when we die. So death is essential. Living forever is a most horrifying concept, I find.
And for a photon, the idea of traveling forever must also be a horrifying concept.
The photon will move continuously. Only thing, it will move with depleted energy. It will become so slow, its wavelength will become so large that ultimately it will be difficult. So actually, I wanted to do some work in this. That means all the photons which are going away, they are losing their energy. But statistically, whether it will be possible to show that the effect of this is in the form of cosmic microwave background radiation. That's what I wanted to do, but I'm not able to do it. But I have a feeling that it can be done.
Is there such a thing as a graviton in the
graviton concept I had to bring, because any effect across space you have to explain. You have to either use some moving particle like photon or graviton, or some wave, so, or a field into C. But I think field and particle concept has always existed simultaneously. The same field can be considered as also a moving particle. So whether gravitons are as particles or waves like photons, I don't know.
So
Those
you don't feign any hypotheses as
No.
to the
I just use the
cause
term
of
graviton.
the phenomena.
Yeah, I have used the term and graviton, which carries the gravitational effect.
Hmm.
When two bodies are interacting, there must be something which must be exchanged between the two. So that standard thing which every physicist does, I have assumed that. So
Can you envision any other experiments that
most important, I think, is to
I believe
measure
you have an experiment in mind.
in.
I believe you have an experiment in mind.
No, my only important experiment, the effect is so small, you see. You must find out a phenomena which is free from pollution. Pollution, I mean to say, too many other effects influence the result and it gets difficult to detect. So one clean system is Mars. In the Mars, has been a planet which has helped us in establishing Kepler's laws, as you know, because it was Mars's little bit of eccentricity in the orbit that made the 8 minutes of arc not matching a circular orbit. And I think that's what made Kepler convinced that it will be a non-circular thing, and he came up with that idea of elliptic orbit. So Mars will again help us in finding out or resolving the issue. If Mars has a secular retardation as approximately 1 into 10 raised to minus 22 radian per second square, where the angular momentum is going and how. So therefore that experiment, if NASA does, which maybe they will do in another couple of years' time, so 5-7 years of data collected by that experiment will be able to decide something. So this experiment of measuring Mars's rotation rate very accurately over the years, that is essential. And other experiment I have in mind is a terrestrial experiment. Now, if a photon moves away, it is subjected to a gravitational redshift. And when it falls, it is subjected to a gravitational blue shift. So if a photon goes and comes back, according to conventional theory, its wavelength should not change. But when it goes, and if velocity dependent drag is there, then it will have an excess redshift while going. And while falling also, it will have an excess redshift. So that will add up. Now that amount will be different from if it moves horizontally on the Earth's surface. That I have calculated. So if a photon goes this way and comes back, the excess redshift it will be subjected to will be different from the way it goes up and comes down. So if you can have parallel mirrors here and parallel mirrors horizontally, so if you can compare the light beams and the difference in frequency detected by a fringe pattern or by modern technology of measuring directly the frequency, that may show the effect of the velocity dependent term. Because gravitational redshift term will be gone, because once it goes it will be positive redshift, when it comes same amount of negative redshift. So when it goes again and again and again, only thing which will remain is the drag term. It will keep on adding term. Here also the same thing goes and forth by the two mirrors reflecting again and again. It is the drag term which will remain. But the amount of the two drag terms can be calculated, has been calculated, and can be compared. Now if I keep the two sets, one is this and is this, first incline in 45 degrees like this. So it will be identical in both cases. So you adjust it to a zero position for calibration. Then you change the inclination like this. So one is along this, one is along this. you will get a fringe pattern or a difference in frequency, whatever method you use. Another thing is, if you do it, again the same kind of difference will come, maybe, but in the opposite direction. So this experiment, if can be done accurately, because the values involved are very small, then it will be a definite measurement or proof of the existence of a velocity-dependent drag on photons. So this experiment, I don't know which university can do. In India, we cannot do. It is very expensive, such kind of accurate experiments.
Mhm. Does inertial induction change measure the strength of gravity in any way that could be measured?
What?
Does inertial induction change the strength of gravity just between stationary objects, let's say?
No.
That could be.
Because the moment they are stationary object, no relative motion, the inertial induction doesn't come into picture.
And of course, all objects are in motion.
Yeah, then that effect is there. So you see that I think the direct proof can be by an experiment using light, as they did with falling photon experiment. Only difficulty is that till today there has been no experiment which measures the actual redshift by gravity exactly. There will be always some other effects. So that has never been possible by one-way measurement. Okay, our redshift should be 2 into 10 raised to minus 15, and I get it. They have never got it. They got 18, 14, subtracting this, dividing by 2, and then they got the actual value. So that way the velocity-dependent drag term gets cancelled out all the time in all these experiments.
Would inertial induction have any application in particle physics?
I don't know particle physics.
The particle accelerators.
You see, particle physics
Hadronic
always
physics.
deals with small particles, so small that inertial effects are, of course.
But in accelerators, accelerated to very high
Yeah,
velocity.
definitely. But actually, I had thought about it this in cyclotron experiments,
Mm-hmm.
to measure. But there, the drifts, etc., are much higher order of magnitude, and you have to constantly adjust by external effects, control it.
Yes.
So it is not a purely isolated system.
But
Otherwise, it would have been possible. But we cannot do it. It is
have
so
you
small.
considered the phenomenon of Bremsstrahlung, braking radiation,
I don't know.
loss of radiation by loss of energy by radiation of an accelerated particle?
Bremsstrahlung. I don't know. I'm not considering that. But the matter-matter interaction, wherever I have applied, it has shown that it explains the things which are difficult to explain or which can be explained by some ad hoc assumption. And also photon-matter interaction shows the results which you have got. It matches some of the past observations.
Mm-hmm.
Actually, the difficulty is that nobody has ever anticipated a velocity-dependent drag effect, because it was always thought velocity does not produce any force. So therefore, never any attempt has been made either to measure, like say for example, the grazing of light, So if it is possible to have this experiment done, like say when Jupiter is almost on the point of eclipsing a star, measure the redshift of the star. Those things could have been done if people expected something. But according to conventional science, if light photon is coming, it will be subjected to blue shift when it approaches, and the same amount will be taken away by the same amount of redshift when it goes away. No resultant redshift is expected because the potential here and potential here are same gravitational. But here there is a drag, so when it is coming like this, continuously it is subjected to a resisting force. So it's reflected in an excess redshift. So, but had people expected this in the conventional physics, they would have made experiments, but nobody has expected and no experiment has been done.
But we have the example of the limb shift, which is
That I'm saying. So they tried to explain, they have found it very difficult to explain, but such things are there, and with this you can easily explain, and but without that they have all types of mechanisms to express that how come that excess redshift they have.
But there are huge catalogs of data on gravitational lensing in
You see, gravitational
in astronomy,
lensing, I'm telling you,
which should also produce
it is
an excess redshift.
primarily, no, lensing is mainly due to the bending of light, lensing effect.
But this is a grazing effect.
Which one?
Lensing is grazing. The
Uh,
photon grazes
Yeah, but this
a
thing
massive
is this,
object.
but you see, to find out or detect that frequency shift,
Yes.
I think you need kind of information which they don't have in this gravitational lensing.
Well, perhaps there's some statistical analysis that could
Maybe,
yield
but you see, again, the results will be something, I have got far more concrete things here. And trying to show some kind of a small effect in gravitational lensing will be far less convincing to others that this extra effect is there. Because there are far better examples very nearer home. Why I have to go there? The solar system is there. Gravitational lensing is always an extragalactic astronomy affair, you know. So involving quasars, you know, which are very far off, other galaxies, you know. But we have so much at our hand, very near solar system. So if somebody can develop a technique by which, because you see, Jupiter is a large mass, you know. So whenever a star is occulted by this, occultation takes place with Jupiter, if the redshift is measured, normally people have always measured the bending because they thought that is the effect which has to be detected. Nobody has looked into the redshift part. So had it been done, that would have been there, but that was not expected, except in some rare cases. Is it 12:30? You can open it.
Sorry, you were saying?
If somebody.
Do you want them to return later?
Yeah, I think that will be better. I will leave at 12:30.
On va partir dans une vingtaine de minutes, peut-être 30 minutes.
Yeah, I think 12:30 I think should be done. So I think, Roy, you see, there are many things. Only thing, you know, if the mainstream scientists feel that something should be investigated, then accepted. That investigation requires certain effort. And I think I personally feel there are ample evidence that something, this may not be an exact theory because it is a kind of, I'll say, as yesterday you were saying, that particular term, phenomenological theorem. It is so. It is not derived from something very fundamental like particle physics or so. So since it is a phenomenological theorem, just like gravity theories are all like that, except relativity, where it tries to explain with the help of space-time curvature. But I think till today, there has been no evidence of curvature of the universe. And still more intriguing fact is that you can see very well-formed spiral galaxies with a redshift of 6 or 7. That means they are very old. Now, according to standard model, that if it started 14 billion years ago, it will take very long time to form these spiral galaxies. You cannot see spiral galaxies with such large redshift, which means that they are very old also. So there are indications that perhaps that is the standard model has problem. The universe is infinite, both in time and space, and non-evolving, and there is no expansion. Universal expansion, I mean to say. And my only two things I feel I like to happen. One is that terrestrial experiment, which can be done. Another one is the measurement of Mars spin rate very accurately and to detect if any secular variation is there. And I will try to do personally see that if cosmic microwave background radiation is nothing but these photons which have lost most of their energy, and statistically that is a particular wavelength where they are maximum visible kind of thing. That can be done without much problem because I need students, but I have never given this work to our students. Okay, this is non-standard physics and it may create problem in their career build-up. I have tried to jeopardize my own career without doing anything. But I think the recent work which I have done applying this to Lagios, it shows that it fits in very well. I have always tried to figure out and find out something which will decidedly prove this theory to be wrong. And I can have peace of mind, forget about the whole thing. But I have not been able to do that.
If you've taken pains to protect the careers of your students, have you considered collaborating with someone whose career is already in jeopardy, such as Narlikar?
Narlikar, actually, you see, any scientist or any astrophysicist or cosmologist who has his own theory, so his primary intention will be like Tycho Brahe. He always tried all his whole setup to establish his model. That was his primary thing. So Professor Narlikar has his own theory of oscillating universe, and he definitely is one of the most competent cosmologists. But his intention is to establish that. So the persons I have been able to interact with, like David Roscoe, he doesn't have any major theory of his own, or Andre Assis. No problem, they all feel that something is there. Not only that, very funny thing, in our IIT Kanpur, we have a very strong physics department, and the most respected physics professors, who don't have any particular attachment to a theory, they all like this. I had given 2-3 seminars in the department. Then they sent, in the long time back, I'm saying in the 80s, they sent my papers to another very senior physicist, theoretical physicist at the Raman Research Institute, Bangalore, Vishes Raya. So he has his books also on relativity and universe, physics of the universe. So he sent these papers to another very eminent cosmologist, Roy Choudhury, who is respected by all. He told me, once I came to know that he has got all those papers, he said that all these matching of results cannot be pure coincidence. It doesn't happen, particularly with this kind of order of magnitudes. He said there must be some hidden underlying physics. It has to be unearthed. So it happens when the existing situation become alarming and people will have to do something about it, then they'll do. Otherwise, like your epicycle theory of Ptolemy, so long as they will be able to match the observational result with little bit of modification here and there of the standard model, they will keep on doing it. So, but I think as the technology progresses, when you will be able to measure frequency change of the order of 10 raised to minus 20, 10 raised to minus 18, many new phenomena will come, and these kinds of things can be easily detected.
Why do you mention 10 to the minus 18?
Because I think our current capacity is to measure redshift of the fractional redshift Z equal to 10 raised to minus 6. The moment we can do it by 10 raised to minus 7, we can detect the frequency shift of objects which are being occulted by Jupiter or even by Moon. So when a star is very near Moon, we see the frequency of that light coming from that star, and when that star is away from that Moon, the change can be detected.
Should it not be possible to reproduce such extreme conditions with lasers?
No, no, I'm saying your distant star is not emitting laser. Huh?
No, but
Yeah, they have done, like say Pioneer. Then you send a satellite on the other side of the moon and let the satellite send a light beam, laser beam, which graze past moon and measure the frequency. Yes, you get it. Pioneer 6 signals, which I am saying, they are all artificial signals, and that result is there. There was a frequency shift when it was very near the solar disk. Moment it went away from the solar disk, it came back to the original frequency.
yes,
It is there. But people don't take this very seriously or not much importance, because things are generally put under the carpet whichever doesn't fit your scheme of things. In science it is happening every time.
are there any other topics that you would like to cover while we have a
Not
few more
exactly.
minutes?
I say that this Mars experiment, it can be done by NASA. I have discussion with Dr. William Faulkner. So he is an expert in this line, and he hopes that with the technology we have, it will be possible, but it will take a few years' time. I again have a meeting on 27th or 26th and see what is the progress. The other thing is that I would like some major laboratory to conduct that experiment. That two right angle beams of lights, when they are at 45 degrees both, they should be symmetrical. Moment you do it like this, one horizontal, one vertical, the effect should be detected.
Would you like to launch a formal invitation to a laboratory now?
I'll try. I'll have to first draft a paper giving the actual expected values.
We can present this video as a rationale for the experiment, if you like.
Yeah, if they want. But I think papers are there. But I think I will write a paper, not paper, research paper in that sense, but giving the values kind of things which are expected with this experiment. That I have started working on. But I don't know whether anybody will conduct that, because it will be an expensive experiment. I discussed with my sons, So my elder son, who is in AT&T, I said that if Bell Lab could get a Nobel Prize, why not AT&T? Do this experiment. He was laughing. But I think my another son, who is actually, he was a faculty at Illinois, in Raytheon, they have resources to do these experiments. But I think here, most of the things are, anything which is expensive, you need very strong justification.
But this is not a tabletop experiment.
It is a tabletop kind of thing, a laboratory experiment.
But not in someone's basement.
If somebody has that kind of clever mind to do that thing, basic idea is very simple. The light beam going up and down few times vertically and few times, same number of times horizontally. So the velocity drag term will be different and they will be visible. And the usual standard gravitational potential, that term, that will not be present. Because in horizontal it will be zero, in this case they will cancel out each time they go up and down. And horizontal cases it will be zero because potential is same in both the places. So on principle it is a doable experiment.
I look forward to seeing it done.
Yeah, let us see. If you could have some laboratory here, a Nobel Prize is waiting. Because if you can establish this phenomenon, it's a completely new thing, and it changes many ideas, including the model of our universe. Actually, that is also an hindrance to any kind of progress in this, because you cannot upset too many cards, people have a lot of vested interest. So if you now suddenly prove by experiment that the universe is not expanding, what happens to hundreds and hundreds of researchers who are producing Big Bang, 3 seconds after Big Bang, these all kinds of exotic models, hundreds and thousands of research papers and millions and billions of dollars in experiments, and they'll all be useless.
I won't comment.
Yeah, better not to comment, because in science what happens, ultimately truth comes out. Though
Yes.
I think for 2000 years people tried to prevent any concept of heliocentric model, ultimately it came. You cannot stop it. It may take time. But these experiments can be done, but since most of these experiments are very expensive, who justifies the fund expenditure of this fund? That is the main thing. I will see that if some physics professor or electronics professor or optoelectronics expert does this experiment, it is possible. It may require perhaps a couple of $100,000, that's all.
Let us investigate.
Yeah.
So shall we?
Yeah,
Shall
I
we end
think
it
this is the point I think we should stop.
You've made all the
Most of
points
the
you wish to
important
make?
things I wanted to say I have said, but the main thing should be kept in mind, the basic factor, the velocity dependent term which I added, it has brought many fundamental changes. It is not only that making the value of two masses equivalent, that is one thing, but it has made very profound changes in the concept because of the cosmic drag. Our whole universe looks different. Other effects, Earth slowing down or excess redshift here and there, they do not change much of our picture of the universe. This way or that way a little bit. But cosmological redshift being not of Doppler nature changes lots of things. And that is what actually is a cause of concern to many in accepting this theory.
So thank you for your frank discussion.
Thank you, Roy. Thank you. Hopefully this